Hello everyone, my name is Daniel Kim, and I chose a paper called Using Platform as a Service for Better Resource Utilization and Better Quality Application. This paper appeared on International Journal of Innovative Research in Advanced Engineering, and it can be downloaded on this site. First, the authors wrote about the basics of cloud computing. We covered some of it in our class. He talks about the three fundamental models of cloud computing: the infrastructure as a service, platform as a service, and software as a service. Infrastructure as a service is the most basic cloud service model that's available, offering physical or virtual machines and other basic resources. Typically, it offers virtual machines or VPS or virtual private servers, disk images, raw file storage, or even lower level services like firewall, load balancer, virtual local area networks, etc. Software as a service offers the most advanced level of cloud computing with high level of application that are specifically designed for certain purposes. Cloud providers provide and create and run these applications, and the cloud users don't have to know anything about these infrastructures or its internals. Finally, platform as a service, which we'll be discussing, if it's right in the middle, where it provides a computing platform such as a certain operating system or a programming language execution environment, database, web server, etc. It's typically used by application developers to write and run their software. One example is Windows Azure, where cloud users can create and run applications based on Microsoft technology based on .NET, like ASP.NET or C#. The authors wrote that platform as a service is the most important model out of the three models because of the belief that most infrastructure as a service will shift to platform as a service. Also, they believe that most organizations will move from their physical IT infrastructure to the cloud, especially toward platform as a service. The benefit of platform as a service is that cloud is very easy to maintain and operate from the user's point of view, and that it can be done by a small team. However, there are some caveats and difficulty with working with platform as a service. One of them is that users need to think about how the existing applications which are running on organization's server and not in the cloud need to be modified so that it can run in the cloud. Second is a deployment issue, especially deciding on how the resource should be provisioned and managed. There's this difficulty that comes mostly from setting up the system initially. The rest of the paper then discusses the three types of techniques that deals with some of the issues of platform as a service, especially with setup and deploying them. The first technique that was discussed was originally proposed for a cloud computing lab. It uses a web portal for all user interactions. Users can select operating systems and select the applications that they need to run via choices on the web interface. There's also a backend database to keep track of all the resources and user informations. There are three main modules. The first is the user management module that provides user interface via web. The second module is called resource allocation module that manages all the resources and runs the applications. Connections management module interfaces users' access to the resource. The system is very simple and mostly controlled manually by the users. The most simple cloud vendors operate this way. The authors recommend this for educational environment as well as for small cloud setup because it is very simple to create and maintain. Another technique is called platform for the integrated mobile applications, and an example is called Cosmos. This is a diagram of their architecture. It uses mobile applications and offers better user experiences, at least according to the authors. Instead of one monolithic web portal like we saw in the previous technique, It uses suites or multiple external mobile applications that know and interact with the data and the resources in the platform as a service. The system intelligently determines the platform as a service need and runs and scales the system based on the required SLA or service level agreement, which is set by the users. Mobile applications talk to the Cosmos system via API and SQL queries. This is focused more on data access and sharing instead of efficient resource utilization. It's good for data exchanges between applications, and API hides the complexity of backend database infrastructures. For me, this reminds me of a service like parse.com, where app and mobile developers can read, write, and exchange data easily in the cloud. The final technique is an open source platform as a service with automated resource management. It uses an architecture called Mosaic. It's for open source API and platform for multiple clouds, and it uses open source tools and solutions. I apologize that this diagram is not very readable. It was the best I could get from the paper. But as you can see, it looks quite complex. This system allows automatic resource provisioning and management. It decouples deployed applications from underlying architecture, and the only thing that the applications need to be aware of is the common API to the cloud. One main benefit of this architecture is that it overcomes the platform as a service's greatest weakness, which is its lack of interoperability between cloud vendors. It can connect to different virtual machines like Xen, KVM, or LXC on various Linux platforms, as well as commercial cloud vendors. It is completely vendor agnostic, so user can theoretically switch from one vendor to another without any serious repercussions. It's also independent from any programming language, so it can be done in Java, Python, .NET, etc. It's based on open source, so apps connect to the cloud using a cloudlet API, which connects to the connector API. Users use the application tools to create descriptors to help developers in deployment. These are basic requirements for applications that run on the system. It is also very granular, meaning that each component or application can scale on its own instead of scaling by virtual machines. So certain applications can elastically grab more resources as it needs it, while other applications may not need so much. The authors believe that this is the best solution for business needs, but it's also quite complex to implement in all levels, including additional development, especially for migrating existing applications to the cloud. My takeaway is that even though software as a service and infrastructure as a service have bigger spotlights, I agree with the author that in the near future, platform as a service is going to be a very important model in cloud computing. As an example is Heroku, a very popular platform as a service used by startup developers because it enables them to create infrastructures very quickly and easily, and more importantly, they don't have to worry about maintaining the IT infrastructure. I've used the service before and it is dead simple and easy to use. A lot of web applications and software as a service are actually running on Heroku right now, so platform as a service like Heroku is the backbone of cloud and software as a service. The cloud is still fairly new and constantly innovating, so we will see more innovations and evolutions and systems like the ones that authors wrote about. There's also new standards that are emerging in the industry. For example, there's solutions for managing clouds like Apache CloudStack, there's Eucalyptus and OpenStack. I think we'll see new innovations and more open standards that will remove some of the negative aspects of cloud computing in the future. Thank you.